So students, you got to know that according to the third law, every action has equal and opposite reaction. Now what happens if in a system 1 and 2 second that two bodies are colliding to each other and both are having a very different masses? So will they actually applying equal and opposite force on each other? So here is a situation, students. How does it work? Yes, they are actually applying equal and opposite force on each other, but there is certain phenomena that is working behind it, and that is conservation of momentum. Okay, so what is conservation of momentum? You heard about momentum already. You know that the momentum is nothing but the impact that is applied by the any object which is actually in a motion. Okay, no rest body is applying any momentum. Like a ball is here, and if we are saying that this ball is applying any momentum, not at all. Okay, if it wants to be applied, then it might have certain velocity in it, because this is certain object, so any object would definitely having certain mass in it. No physical object is actually possible if it does not contain any mass. Yes, how would you see that? Okay, now because it is certain object, so definitely it is having certain mass. Now if that mass is moving with certain velocity, so we can say that there would be certain impact on it. Like if I am throwing a ball toward you and it is thrown towards your face directly, now would you get certain impact of that ball? Yes, because it is having certain mass, and because I am throwing it with certain velocity towards you, so now it is generated certain momentum, that is impact. Okay, so what is conservation of momentum? Conservation means that this thing would be equivalent. Now because the system, when two objects are colliding, this whole thing will become itself as a system. Okay, now this system itself is having certain momentum value, certain force value. All of these certain things that is included in system would be considered as a particular momentum value. Okay, like if I am talking about only one ball is there. Okay, so how we can judge the momentum of only single ball if we are not having different object on which we are throwing it? Okay, because now we are having a formula that the mass multiplied by velocity will gives the momentum. Okay, that is fine. But if somebody wants to feel that, okay, like what is going to be response by the other body? So here we can say that when two or more bodies act upon one another, so now total momentum remains constant. Okay, that remaining constant is actually the conservation of momentum. Okay students, so here this conservation of momentum gives us an idea that in this system, if these two balls are colliding with each other, so the overall value of the momentum before collision and after collision would be same. Okay, so we can say here like this: momentum before interaction of the two bodies is equals to momentum after the interaction of the two bodies. Let us elaborate it more with an example. Okay, suppose there are two objects. So before collision, these two objects are moving with certain velocity. Fine. So M1 and M2 are the two objects and they are moving towards each other. M1 is moving with a velocity U1. Here, why we have written here U1? Because it is initial value, like the starting one. Okay, and the value for the second body is the U2, that it is moving with the velocity of the U2. Okay, now they are not have been collided till that. Now, if they collide with each other, so what would be the after collision value? Yes, this is the after collision value. Their mass would not going to be changed because mass is constant value. It is a scalar quantity. So mass will remain same, but here the velocity of these two objects would be changed after collision. They might collide and they might go with different velocity now. Okay, so as we can say now that let's suppose the M1 now having the velocity V1 and M2 now having the velocity V2. Okay, so here students, force on the object 1 that we have seen here would be the M1, and acceleration would be A1. So we can say force would be M1 multiplied by A1. Okay, that is true. Now force is equals to acceleration, that is equivalent to V1 minus U1, because you know that acceleration is nothing but the change in velocity. Change in velocity per unit time. Okay, this is what acceleration is. So, on place of the acceleration, we have written here the final minus initial velocity divided by time. Final minus initial velocity. You know, student, that this formula, we have discussed this thing in the previous chapter, and the final is actually after collision thing. So we have written here V1, and the initial is the before collision value. So we have written here U1. We have done nothing here, just the force value we have taken for the two objects. Now, because the acceleration that is produced inside the body after collision is this, the force that it is experiencing, the object 1. Okay, there were two objects, fine. So according to that, now if we want to see the force on the object 2, again the same thing will work here. So M2 is the mass of the object 2, acceleration will be A2, and now we are having force for the second object, that is M2 multiplied by A2. Okay, that is fine. Now again, because this were moving with the velocity V2 after the collision, so we can say that here the value for second object acceleration value would be V2 minus U2 divided by 2 and T, and the acceleration is because of the collision only. That change in velocity happened due to collision. Acceleration is change in velocity with respect to time. At what time duration we actually seeing the change in velocity? Earlier it was moving with the velocity U2, and now it is moving with the velocity V2. So here is the change, and that takes time. So here is the acceleration, and according to that we are having the force value also. Now students, as you know, according to the third law, we are having nothing but the force exerted by the A object is equal to the force exerted by the B object in a same system, because we are talking about only these two objects right now. I'm again and again speaking the same thing in a system. So system is nothing but we are talking about only these two bodies. I'm not talking about any car or any truck, plane or any bird. Okay, I am just talking about these two balls. So this is the system for a while. Okay, so here this A body is exerting a force on the B1, and the B1 is also exerting a force on the A1. So we can say that according to the third law, these two are equal. Okay, now we can keep the value of force in both cases, as we have find out the value of the A force that has been exerted here, FA and FB. So these two are equal, M1 V1 minus U1 divided by T, M2 V2 minus U2 divided by T. Okay, so now as you know, T to T would be cancelled because these two get changed in a certain time, and that time would be equal for both of these balls, right? So here beneath the value of T to T would be cancelled, and now we are having this equation, that is M1 multiplied by V1 minus U1 is equals to minus of M2 V2 minus U2. Yes. So why I have taken here minus sign, student? Because you know that the force 1 would be exerted in equal and opposite direction. Opposite direction is working here. That is why we have taken here minus sign. So don't forget to put minus. That actually shows the force that is applicable on one body would be opposite in direction to the other body. If we are taking this as a positive, this would be negative, and if this would be a positive, then this would be a negative itself. Okay, so now because you can take any of these two values as a negative, we have taken the force 2, that is B part, B ball is having the negative 1. So now M is taken as minus here. We have taken the minus sign in overall equation. Okay, now solving this. Okay, so by opening this, you can multiply m1 with the value of v1. So you are getting m1 v1 and m1 multiplied by u1 m1 u1 minus sign is equals to minus m2 v2 minus m2 v2 minus m2 minus u2. You know that minus and minus multiplying become plus. So here we are having plus m2 u2. Okay, so now arranging these two numbers, if we are taking the v1 and v2 together and u1 and u2 together, so we can shuffle it. Okay, likewise we are transferring the negative term on this single side and they will become positive, and v1 v2 on different side. Okay, so here m1 v1 and m1 v2 we have taken it to the left side, so m2 v2. Now m1 u1 would be taken to the right side, so they have become equivalent to each other. So now student, as you can see, before collision and after collision. Okay, let's suppose this system is of the after collision part. Okay, after. So before they were moving towards each other like this, and this was u1 and this was u2. Now in the before part also they are having certain momentum. Am I right? Yes. This ball and this ball together would have certain momentum. If this would not have been collide with this or collide with any object, it would give certain impact, and even this would, if it is not collided with this would also have certain impact on any other object. Yes, by totaling that two part, now we are having certain total momentum for this before collision part. Now after collision part, again if we are taking v1 v2, so see students, before collision and after collision they automatically get equal because of the third law of motion. Okay, so this simply states that v1 and u1 and v2 and u2 after collision equals to the before collision. Okay, so the total momentum conservation, because momentum, we have seen that momentum is nothing but the mass multiplied by velocity, and here also we can say the same thing is happening, mass multiplied by velocity, mass multiplied by velocity, mass multiplied by velocity, mass multiplied by velocity. Okay, so all these values are actually momentum, but adding u1 and u2 वाली value जो हम add कर रहे हैं, that is the previous momentum and this is the after momentum that is seen here. Okay, so this predicts us, give the idea that the final momentum of the two objects, that is this value m1 v1 plus m2 v2, and the original momentum that is before collision is equivalent to m1 u1 plus m2 u2, and these are equal, and we have proven it. Okay, so thus we can say that this is how momentum of any system is get conserved. Okay, so this is the last part of this chapter, students, and you know that this was very interesting and very easy. So keep it in your mind that how does three laws of motion actually work, and Newton was very genius scientist, student. So kindly follow any of his theories and any related things that we haven't studied yet. You can find out very more interesting ways, and why not to check out to the MCQ part also, so that your concept will get more clear. Thank you. All the best.